video, I'm going to describe the eliciting students' ideas practice in the context of the It's All Connected data puzzle. So the goal of this practice is to bring out student ideas about an opening scenario. Could be an image or videos, a question, or a demo that has similarities to the science investigation presented in the data puzzle. So these student resources, experiences, ideas, language, they can be used to help students make sense of new complex science phenomena. So we want to bring out student resources about an event that students might be familiar with that has similarities to the science investigation that they may not be as familiar with. All right, and then we want to connect those two. So using resources to help them feel more comfortable about something new. Facilitation strategies for this include utilizing the opening scenario as a warm-up prompt, something that they could respond to in a science notebook, through a think, pair, share discussion, or a whiteboarding or butcher paper activity where students respond to the opening scenario in small groups. I really want to point out here that the opening scenario included in part 1 is not included on the student worksheet. So this is meant to be completed before you distribute the student worksheet. The opening scenario for the It's All Connected data puzzle looks like this. What do you notice and what do you wonder about the runner pictured below? And so you can see in this opening scenario, you've got the same runner, the same temperatures, and what you'll notice is that she pulls her hat off in the second image here on the right. What you can see is some of that sweat, that perspiration is starting to be released off her scalp into the air without that cap on. And so we would expect students to identify that difference between the two images and maybe have some thoughts about why this might be happening and be able to share a time when this may have happened to them when they were wearing a hat and they were really working in cooler temperatures. And what happened when they pulled that hat off? Did their head start to steam? And make note of these student experiences in language, because those again are things that you can refer back to later on in the data puzzle. We want to try to think of other examples now where having a barrier such as a hat or a pot covering a boiling pot of water might prevent the transfer of moisture. That's a key component of this data puzzle. So we've got the runner with the hat on. We've got the boiling pot of water with the lid on. Those effectively are trapping moisture, but when you remove that hat and you remove that lid, moisture is able to escape. And so Gina Joseph is studying something similar. She's studying how Arctic sea ice, a barrier, affects the amount of moisture that moves between the ocean and the atmosphere. So Gina is an atmospheric scientist at the University of Colorado Boulder. She participated in the 2019-2020 Mosaic Arctic Research Expedition, and she used a drone called the DataHawk 2 to measure the transfer of moisture and energy between the ocean and atmosphere. And so she's particularly interested in how sea ice might affect the transfer of moisture between the ocean and atmosphere, and what that might mean in terms of its impact in the larger Arctic climate system. So that concludes the part 1, eliciting students' idea. We engaged with an opening scenario, with the runner with and without the hat. We saw the pot covered and not covered, and what that does for the transfer of moisture. And that's kind of analogous to what Gina is looking at. How does sea ice act as a barrier preventing the transfer of moisture, and what does that mean for the larger Arctic climate system? Now students are ready to engage with part 2, identifying important science ideas, where you distribute the student worksheet and we explore Gina's work a little bit more deeply by looking at the interactive reading the puzzle plot text.